Hey, babes in Toyland. We're back. Um, it's been a pretty wild ride. Uh, this the new fixture has spiraled completely out of control, and it is pretty much there. It's taken me a couple weeks to get dialed in. Um, Initially, this was going to be the Skynet 2, but because enough has changed in certain ways, the inverting of the pivot, I think, helped with that. Changed the name to the Samantha, um, and I think that having a new name is fitting for this. It's pretty good. Um, so let's take a look at it and what makes it so cool. So the primary new thing here is that we're taking more of the welding breadboard, the fixturable tool breadboard, and we're actually cutting up a few segments from a larger table, and we're building it into an 80/20 rail. Um, this was the huge thing that really tipped things off. If we go to the blog post, initially, so I had a problem with the Cyberdyne. These pinouts that were meant for being able to use the fixture on either optical breadboard or welding breadboard. It actually turned out that I was never really going to use it on an optical breadboard. I mean, I have some, obviously, there's some right in front of me here. Um, but over time, the welding table has become my go-to place for fixturing. And getting into that ecosystem has been one of the greatest boons in terms of how I'm looking at problem solving in the shop, um, and doing more complex setups. Um, let's see. So I've got this, the table here. This is a photograph of a bike being fixtured on it. You see over here, I've got some handlebar, uh, a sub-assembly bolted to the table, and I've got these towers here that are components within that ecosystem, and these I made. And they hold the handlebars together while I weld them together. But that same fixturing I can port over to the mill and use for milling operations. So when I'm making a fixture that hold for welding, I end up with something that I can machine with as well. And then when I'm spending the money, I actually save in the long run. Another issue I was trying to fix here was I was looking at some rail. So this is SGR 20 rail here, that's a reasonable facsimile, to get away from that pinout, which was a real frustrating thing when using the Cyberdyne. And those two things working together, when we get over here, we can look at this nice rail. I put a ton of work into these carts and the axle tower and some other details. I'll go through some different parts of it. Well, let's start with the axle tower, just because that is kind of cool. Um, One of the problems with the Cyberdyne, it was a bit of a challenge to calibrate the tower as had designed it. Um, we're going to open up the separate subassembly here. Okay, so what you see here is this is a slide rail. We've got a keyed Delrin key in there. Oh, where'd it go? It's not showing up. Delrin key. Oh, it's on the other side. Okay, I've got to fix that. Somehow it jumped over. Um, anyway, it goes in the slot on the other side. If you notice, there's also, let's hide these guys. Notice I've got some pinouts on the back side here. This is so that when I can take this tower off my fixture and connect it directly to the table and have it indicating off the pins, which is pretty useful. I've got this registration here, 100 millimeter increments, and it goes down 10 millimeters each time. So we go from a height of 200 millimeters for the center line and down 190, 180, 170, 160, 150. So we've got some various heights we can use. But the real cool thing here is what we see at the top. This is a tool. I'm going to hide this guy. Okay, so we've got a tension rod that's holding that assembly together. We've got some pins in it to keep it from twisting all up. But then, rather than using the extrusion holes for connecting, I'm using those extrusion holes for these set screws that I access through that whole route. And I can tilt my axle tower relative to the base, which is really rad. You know, all these, anywhere you see on the fixture, these turn handle things, they're in recessed pockets, just like this. And you can replace that with just a standard quarter 20 socket head cap screw, and it'll be flush on the top. So you have an option, or I have an option, of whether I use the turn lever or a fastener. But everything's flush on the bottom when I remove it, and I can take out my clamp for the 80/20. And I thought this was really cool. Oh, we got a mistake here. That nut should be seating directly on top to hold that in position. So that's an update problem. But you can see we're cutting it a little close here on this tool. But I can do some modifications to that. This is out of the McMaster tool, just showing that going through there. I think I can get an even longer one. So that's pretty cool. Just the two main things on this axle tower is that you can bolt onto any surface, hold your axle stuff, or put it on the 80/20 rail. Let's put that all back together again. Show. All right, let's close this up. Let's say no. Oh, whatever. And there's more back here. Let's go to the arm assembly. Come on. I think I really dug deep into every part of this. Okay, so the axle holder subassembly. So this is pretty cool. Still pinning out at 100. I was going to do this off center. I ended up doing it on center. And you can see that even though this distance here is not 2 inches, we're stuck with 1.5 because of the 80/20 mount for those screws. Once again, we used the 5/8 inch land there. Now, you can be on a 5/8 or a 16 millimeter table. 5/8 tables, what do they go to? 627, I think, are the typical hole diameters. And on the Siegmann 16 millimeters, they get up to 630, I think, something like that. So depending on the environment, we might make some adjustments. But this is a 4-inch spacing right here. And that's going to allow me to, I can take this subassembly and clamp it anywhere in the welding breadboard ecosystem, which gives me a whole nother type of thing. And this is the thing about these fixtures that I've realized over the years is that I'm always wanting to do something different or hold something in a new way or try some setup. And by having these parts jump over, so like again, these 80/20 rails, these can be mounted anywhere on the breadboard. So I'll have a rail. We'll get to that later. Let's look at the axle tower and pull that up. Oh, so the big thing, like with Skynet, that was trying to be really cheap. cheap and easy, right? So everything was done, how to make it cheaper, how to make it easier. Now, on this fixture, I was trying to make it simpler, but not so much cheaper. And I was figured I was going to use some CNC parts. I maintained this bottom cup like we did with the Skynet so that we can go clamp onto softer materials, but it's nice that it keeps everything unitized. We have plumbing already set up for this, and we cap this. I'm probably going to do this cylinder. I was initially designing in aluminum. I think I have some chromoly steel floating around that's like a 2.5 inch diameter. Because remember, again, this bolts right into the welding table equilibrium ecosystem, and so this will go onto a Siegmund, or Siegmund tables are about 12 millimeters thick, and a like a Rhino cart top from Build Pro that's about 16 millimeters thick. So this one's set up for both, basically the lowest one. But I use this for aligning frames too. So the frame fixture is an alignment fixture also. Um, because I think it's important, I did go back to the the double cone interface here and with the gear puller type thing because I don't want anything to get stuck. Um, just kind of maxing that stuff out. Um, all this stuff when it fits together, it just becomes so solid and nice. Um, this right here helps us tighten onto the table super tight. Um, when the top knob is clamped down, everything in the whole column compresses into itself, so it gets super rigid. Um, and I think that's a real boon when you have to bend a frame around. I don't know if you'd want to use this as production bending, but in a prototype shop, I think you're perfectly fine for that in that type of situation. Did I? Oh, geez. I hope I didn't save that. Okay. Yeah, I did. Damn it. Okay. Let's go up to this subassembly here. How about these carts? The carts are really cool. I'm going to pull one up. Slider block assembly. Okay, there we go. So there's a lot happening here too. And I've tried a number of situations. Here, again, we have a 5/8 counterboard area there. So we can remove that Delrin key that makes the slide, and we can mount it flush onto a table anywhere. The spacing here is 3 inch. We had to keep it tight. So only one of those would ever be used at a time. But the thing is, it's a nice little feature to have for easier clamping. Uh, let's look at this block here. Okay, that's got registration there for the two different positions. Notice I've got two different 80/20 positions here where I'm bolting through the table. I'm keying with these pins, and then I've got a screw down there for the angle to help hold that. So you can shift it fore and aft, and you'll see both setups on this. So this has got a lot of detail happening here. We've got that nice uh, countersunk area, so it'll do the handle or a flush counter head socket head cap screw. um, yeah, and I'll just have those anodized, and I just need one with these registrations on it, and then it's all set up. I think it's 15 millimeter offset from the mounting face for the pucks here. If you notice, okay, we get into that. That's really, oh, I love the puck, the cones. Okay, so just like everything else, we're gonna mount through a 5/8 hole. Um, Certainly, if you're in a 16 millimeter environment, I think it's a 2,000th shim wrapped around would tighten it up on a 16 millimeter hole. But here we have these nice cones. We've already figured out the plumbing for argon, And you can see that this is a standard uh, shoulder screw that goes in here with a 1/2 inch 13 thread and locates really nicely. And you can go through any material you like there. Let's see if I have any material. Okay, let's go through a big lug. Okay, I'll select that configuration. So a 1/2 inch, like 1.5 inches, like you're going through a full size 80/20. I typically use the low profile stuff. So there we go. We're in a low profile, a high profile situation. Look again, we got the nice engagement. Everything's super easy on the cones. Um, I optimize some of these cones. We can get down to EC34. I don't think EC34 is really worth doing. Um, on the C-tube cone, kind of optimized so that we could use from 27.2 to 35. Didn't really do anything bigger than that. I'm trying to get a really shallow angle there because the shallower the angle of the cone, the more it's going to be able to locate, um, radially, and handle those loads and fit up really tight. We don't want a blunt cone. So that it's really kind of important to do that. If we go to the head tube cone, because head tubes are a little bit bigger, we go to another size, and that again is to keep this shallow. And we're all nice and systematized. Basically, the details are cut out of essentially the same part. Same engagement, same location of the plumbing. This is a pretty slick system. It's taken me a while to get here. Remember, it takes a while to get to simple. Simple is the hard place. Complex is easy. And this can go into all kinds of environments, and you can do a 1/2 inch. If you're going to go through 1/2 inch plate, you could go through 1/2 inch plate. Here's a 0 stack 44 setup, just like that. So got this super simple. Went to an 8 mm thread, 8x1 thread for this plumbing. It's a little bit pricier for this, but we're trying to squeeze a lot of stuff in there. I'm really liking this. This is a way to do it. Let's discard all. I don't know. Of course, that's probably going to grenade us. Okay, so these angles, these are 80/20 standard angles. Now those might not be perfectly square. I think they can be trued up on the mill. So if you get them and they're not perfect, you just take them to your mill, square them up. You're going to be good enough for this type of work. 200 mm from the table surface to the cones is the height. Everything clears and it's a nice tidy package. And remember and also if you notice, ugh, that should have been removed for this configuration. This has a threaded hole going through there. Here, let's pull that up. There we are. So we have a thread there. So you can bolt it in from the back or use the T-slot on the front so that brace can be coming from either side, and then this can go into any situation. Let's see, which is the other situation? It's seat tube support. I think that we'll see it flip. There it goes. So you can see now the T-nut's working. I'm just doing a nice V up here. That's the way we're going to do things. I don't need anything else there, so I clear it out, make it nice and easy to machine with the side of a big 90-degree chamfer. But yeah, you can see that we've got two nice positions with this. That comes in handy. Let's not save anything. Come on. And again, on these CNC parts, I'm trying to do as many things as I possibly can while it's in a CNC machine. let's get to the rail system because that's pretty cool. If you remember, we had a spring. Oh no, we crunched. These are the calculators. We'll go over that in a minute. Oh, it's over there. Yeah, let's pull up the there. The calculations. Everyone loves the calculations. I don't know why it crashed. Oh, here's that cone system. You can see it's pretty well thought out for all different circumstances. Keeps everything nice. Here's our other situation. Let me pick this up from over here. Wait, where are we? There we are. And I'm going to do that and drag it over to another window. Come on. You can see I've got my stuff together. All right. All right. While we open this up, so you can see that Samantha just became the name. Um, it was Skynet 2, so we're right in the midst of it. Yeah, I was surprised when we got to that point. Anyway, got all our details spelled out here. Of course, we've got a kinematically constrained area. It's a little ambiguous in one place. Oh, that's the cool clamp. Oh yeah, if you don't have a welding table, you can make something out of MDF. Nice it's called the torsion box, and then you can just drill it out any way you want. If we're talking about tables, look at all this cool stuff. This is a simple kit you can get, and you can get a ton more. It's all set up for that. All right, let's see if we've opened up. Not yet. This takes a while. There's a lot of stuff going on here. Everyone loves dead air. I had to develop a clamp. I wanted a low profile and flexible clamp that isn't included in the welding table setups. And I devised this one, and it uses a couple special parts. This cylinder here that it's standing on, and we have the special pins that we devised and some washers, but otherwise everything's pretty standard in here. These are available parts. I'm trying to keep everything as much as I can off the shelf, you know. Anytime we can buy all this stuff, it's much, much nicer. Okay, well, let's get into calculations and then we'll talk about the rail. So here's a calculator that I have set up for it. And when we're setting up a frame fixture for bicycles, there's certain information that it's kind of important and critical for us to set it up. These driving parameters here are the ones that I believe are necessary for setting a frame fixture. It doesn't need to be as defined as when we're talking about a bicycle or, talking about the frame. It's looking at it from another direction. So we need to know a few things about it. And from there we construct, oh, and then I give it some fixture inputs. And these are details about it. Now, notice here, this cosine bar in this system, 355 millimeters or whatever, that's 14 inches. It's a 14-inch cosine bar. So here's the pin for the cosine, and here's the pivot. And the distance from that tangent to that face is going to set our angle. And that turns into about 23 thousandths of an inch, makes 0.1 degrees. So, that's a little over half a millimeter increments at 70 degrees, of course. Things will change as you triangulate. But at around 70 degrees, it's 23 thousandths of an inch per tenth of a degree. And that's pretty darn easy to hit. And of course, most people are going to be able to come within 5 thousandths or less in a shop environment. So we have a huge amount of control over our angle, and we need it because we're pivoting in a reverse direction. That's what got this fixture the new name, because the pivots, instead of coming from the bottom, now they're coming from the top. And that gets them out of the way so we can do some other things. Okay, so that's cool. So we need to be able to laterally move these, and we have some information when we're in our calculator, and we do that all in here. 200 really isn't used in the calculation, but it's good for your notes. Um, and then we get these settings right here. That's it. Those are the settings for setting the fixture. It's pretty simple trigonometry to get those. And yeah, it's a nice mathematical shortcut to be able to use a board like this. That's been the basis of all my fixtures so far. Okay, let's go to the subassembly for the holding the angle plate. Okay, I've got, as you can see, when we're looking at the main construction, we're not leveraging a lot of machined parts. Here are a couple right here, but they're similar throughout the fixture. So the sliders and these rail pieces are similar throughout, so they're nice and easy to make. We're relying a lot on these pins. So I've got 3 or 4 different pins that are made. And if you look again, and we'll go through that. Oh, why didn't it go? You couldn't see in there? Come on. Arr! Got some weird display thing happening there. All right, let's open this up. Okay. So here's one of these sliders, and they're pretty cool. Um, Actually, no, 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 no. Let's look at it a better way. Okay, guide assembly. All right, this will do it. Okay, so you see this guide assembly, and I think we can transparent it now. There we go. So I went to just some Delrin turned pins here, and I have a little bit of a gap. I think the total is like if it, a piece of 80/20 is going to be 1.5 inches going through here. It's probably set right now to 1.505 or something like that with a little air gap. It's pretty tight, but not, it won't bind. Notice how those pins extend through the plate and locate this at the same time and then connect everything together. So that's pretty cool. We've got a nice spring and set screw system in there so we can increase tension. And this was to try to get it to glide really nice and be very rigid. I mean, you could push against it and take up the play, which is fine. And there's probably some devious things that can be done by removing the spring and using a hard stop on one side and just use the spring on the other. But I wanted a little bit of plastic to rub against the 80/20. And yeah, so this is pretty nice. It clamps together. I don't have the threads drawn in there. The threads pull everything together. So that's a pretty cool system. Um, it adds a little complexity in the machining here, but since we're going to have that machined, we might as well pack it all in together, right? Go over here. We got these nice magnet things. Those come from Build Pro. There's a cool trick with those. Something I discovered. When you order one of these, if you noticed in my build out here, I've got 2 black phosphate, what are they called? Steel threaded locking inserts or something like that. They're a McMaster item, obviously. These are the numbers. But when we get that adapter from Build Pro, if we order the 1/2 inch 13 one, and this is really cool, that 1/2 inch 13 we can use threading a shoulder bolt, a 5/16 shoulder bolt. So it's great for the ecosystem. And what we don't want, while they make these in other sizes, we don't want any other size because we want it in 1/2 inch 13, and then we're gonna put in our own insert for whatever thread we want it. That gives us the most amount of options. And most importantly, the ability to thread a shoulder bolt right into. So right there, I mean, this will add up to use these. There's cheaper ways around it. I've shown thumb nuts and things like that before, but these come in two and threes. So there's a three, you know, just like that. Um, and these are worth thinking about because then you're just reaching under the table and it saves a lot of fuss and hassle. But yeah, that trick I learned early on that was pretty cool. If you look at over here, the pivot, again, we're just another shoulder screw. And we're going to go in and we're going to lock that. I'm leaving it simple for now, just gentle tension or almost no tension on the 80/20 angle bar. If I want to get fancy later with some spring washers or something like that, I can. But this right now is pretty darn rigid, will allow the pivot and everything. And again, just like I said earlier, we can go with a flush mount or a handle here. Now, I have all three described for the tracking of the rail. I think two is going to be fine. I'm gonna find that out. Also with the clamping, one or two or three clamps for the whole system is going to be fine. There's no need for six clamps to hold everything in place on the rail. Um, it's just that when we have the angle going across, some pins get ruled out and we have to shift it over. So we're trying to have a lot of options available, but it doesn't take much. We do these nice long 80/20 T-nuts that we fabricate out of the raw stock, as I described before. Here's a nice piece of the raw stock. You can cut to any length and make it, and we want it nice and long to prevent the racking. Um, and even if you keep one of these loose and not super tight, it'll help prevent the racking as you slide. We're looking for a nice glide, but super rigid. And remember, this is 16 millimeter steel. This is rigid as hell. This plate, as I have it shown right now, okay, this was actually cut from a stock piece from Build Pro. So we buy one of these and cut it into three sections. You can see over here, the axle plate, the head plate, and the seat plate all come out of this one section. You know, these things add up. It's like, I don't know, 250 bucks or something like that for one of these. Um, and we cut it into three pieces, and that makes pretty good use of it. And you can see here's the axle plate is the middle section. You know, we kept the nice little radii. So you just do a good job. You can clean that up on the mill. Um, but now you have a flat surface, a rastered pinout. It's all ready to go. This is the way to do it. Yeah, you can cut some stuff out of aluminum plate, but you're not going to get this level of rigidity or precision with that and the modularity. We're looking for Legos. We like the Legos. That's why I got into all this. You know, I love the Legos. Okay, what do we got over here? We can look at the pin here. Let's look at one of these guys and just how it's. Oh wait, here. Let's hide this guy. And you can see that these pins actually go into there, into that, and the thread goes into there. We're doing a lot of stuff with little things. So these guys, you know, I'm gonna have to pay for these. These might cost me $4 or $5 each. Um, Granted, I don't need as many as I show, but that's pretty cheap when we think about how much we can get done with them. You know, we'll figure it out. I think there's some economy of scale that's going to happen here. But notice we're relying mostly on pins, mostly on shoulder bolts. Let's add this back. I don't know. I'm having problems with rebuilds. Uh, I don't know what it wants me to do. Um, we're waiting. Okay. So let's look here. So this frame that's on the fixture is the M2F2. I know I'm bouncing all over. Sorry. Okay, so this registration here in this pin position is about 320 as we read it on there. Let's go to the calculator. So head to bottom from pivot, negative 320.4. So we're working just right. Now, of course, I calculated all that. So I have my equations, and you can see I calculate everything here, and 320.4 right there. Um, that's all calculated within this program, or within SolidWorks itself. And then I also have this calculator here because it's kind of nice to, when you're working in the shop, to just type in this stuff. It makes things really simple. And if you have a problem, then you know to look at, if you have a disagreement, you know you have a problem, you should look at it. I haven't decided how I'm going to treat the measures on the rails. Currently, I have the rule, it's reading its position from 0, which is the crank axis right now. I haven't done an offset for this because we see here's the pin, here's the edge of the plate, and here's the actual table reading. Just for this demonstration, I noted here that if you take the table read and add 28.6, you'll be right there. Now, there may be some things that come up and that might be adjusted, but for now, that's how I'm doing it. Now, I could take and tape this rail ready to go so that it's already taken that into account. So you just read it and it's the right number. I don't know. I don't know which way to go on that. Um, let's see. We've got the pins there. Oh, these straight edges are cool. Let's go to the clamp. Okay. Low profile clamp. Okay, it's a flexible element there. So you can see that I can clamp in those positions. If we look here, again, we're just recycling those pins into another little thing so that this complex setup up here digs right in there, and it's super solid and nice, and then we clamp through. We go over here with a T-nut. These guys are cool. Um, you can get the cheap aluminum ones. This is the steel one. Uh, this is the 6-inch steel. So it's a standard Build Pro product. And they have the aluminum D-stop ones that are kind of cool. I use that in another place on the fixture. But you can go up to 10-inch. And these are very affordable. How's this 10-inch? Look at that. That's cool. So we have a lot of choices on how we can do a setup or a clamp or anything like that with an array of these types of tools. So I've got them all modeled out. Now, this one here is for right on the plate, which is kind of nice because it tracks with the slide. You don't have to mess around with anything. I'm trying to be economical with the cutting off of that plate, but if I made them longer, it would certainly help and give me a little bit more room to work with. Um, you can see over here, I've got a different version of that where I'm holding the bottom of this tube where it extends. I have that little nugget that's fastened to the end, and that's a simple hold down. Um, but here I'm coming off the table and I'm going into a T-nut and locking its position, almost like clamping it down upside down type of thing. So that's a cool thing that I developed. You know, when we're doing this, here let's pull up and insert a clamp. It's going to unsuppress up here. Let's see if it even is in the right place or if it blows up because I didn't check this one. Where is it? Was that the head assembly? Where is it? I think it's going to be right here. No? Oh, there it is. Okay, so this isn't perfectly set up. I mean, we can always cut down and insert a clamp. This is standard hardware type stuff. I didn't like how they stuck up like this. They take up a bit of room and they snag. I'm not looking for anything to snag. You can see how much lower profile this guy is over here. Um, Also, the inserta clamps will only work in one direction. I'm actually creating an upside down clamp on that other end. But again, if you just reach down and grab a clamp because you need a clamp, you've got one with an inserta clamp. Um, you can see under here, I'm using the 3-place mags, and these are the 2s for those undersides of those. Yeah, reaching under the table is kind of probably the biggest pain in the neck when you're working with these. Over here, we have a pin on this plate, and we can insert these pins, or we can use those cosine pins as well. And we can actually take a direct table read. So any one of these pins is 2 inches from the center here, and so we could set a pin in here and then measure to this pin, and that'll give us our lateral or longitudinal type positioning, and we can take a direct read off the table just by sticking that in there. So we're again leveraging this this weld setup, and we have another readout here. This is the axle. This is the center, and we have a readout there. And let's look and see what the readout should be from our calculations in SolidWorks. It looks like 399.825. So bam, we're right there. It's working pretty good. So there you go. I really put a lot of effort into this, and I'm excited because I think I've taken a lot of learning in the past few years on how to handle this ecosystem and create something that, once this is done, once all these parts are done, it can all be reconfigured. It all bolts into itself in different ways. Let's pull up this guy here. Okay, like here we go. So here's some stuff that's kicking around my table. I have some other blocks. Now these can be dropped in anywhere on that assembly, and right away I have a block. Here's a handlebar set up right into the table, and think about this. What if you wanted some 900 millimeter wide handlebars these are 16 degrees, boom, you just widen it out on the table and you've got a precise location of the end of the handlebars or close up or whatever. Everything's readable off this giant raster. Here's a, whoops, oh, here's something that can be clamped down with an insert a clamp or something like that. And I've got a breadboard here and I've got a rail and I can put pins in for centering stays or something like that. It's pretty cool. I don't know what more to say, but you know, all of these updates really do a lot to fix issues with the Cyberdyne, fix issues with the Skynet, take learning. I was going to go with these rails and I was like, you know what? There's no reason to do linear bearing rails. All it has to do is be positioned, and once it's there, you want it to be rigid. You don't want it to be rocking around or anything like that. Oh, I'm going to do a fork fixture soon. I need a fork fixture. I'm using that old anvil fixture, and it's a pain in the neck. And hopefully one day, and then you can do a fork as long as the table for the chopper fans out there. What do we have here? Here's a drawing. Oh yeah, Samantha is the AI from her. Okay, folks. If anyone sees any improvements, let me know. Oh, we got to check out over here. Okay. So thanks for tuning in. Hopefully this turns into something really cool. Bye.